Hello everyone, I'm Kusum Kisi. Today in this video I'll be talking about convolutional neural network as a part of assignment 7. Starting with what convolutional neural network is. It's basically a type of deep learning neural network which is commonly used for image classification. It's most popular in learning the complex pattern and features in the input dataset, and it also handles the input data if it has a high number, maximum noise or ambiguousness attached with it. We generally use Keras library available in Python for basically differentiating the two types of images. So talking about the layers that is used in CNN, it basically consists of convolutional layer, then the pooling layer and flattened layer and the dense layer. So convolutional layer is nothing but a mathematical layer that performs a mathematical operation on the input data set. These input data set are first passed through a filter, uh, and then this layer helps the model to learn and recognize the patterns and features presented in the input data set, and it develops a feature map. So pooling layer, what a pooling layer does, it's basically prevents the model from overfitting by downsampling the feature map and reduces the dimensionality of the data. The flattened layers, it converts the output from the convolutional layer into a single vector, and the function of dense is to connect all the neurons in the input layer to other layers by using some activation functions. So talking about the data set, for this assignment I have used uh, the pictures of the road. The roads are both flexible and the rigid rigid roads, which is the location is around the pictures I took were around from the Lamar University's roads, and um, some around my apartment as well. So basically the dataset is collected around within the Beaumont area. The picture contains both the well conditions, which is the road without any cracks on it, and the road sections which have cracks on it. So the for the model development, initially the data has been stored in two different folders, one folder with the on cracked surfaces pictures and one folder with all the cracked pictures on it, so that we can import the data by giving different directory in the Python. So talking about the steps, I'll just want to go briefly on the steps. So first I'll be loading the data in the Python, then I'll be splitting the training and testing data set, and then develop a CNN model. After then I'll compile the model, feed the model for the training data set, and then evaluate the data on the testing data set. So before reading the data set in the Python, what we need to know about the dataset is that before analyzing the data, we need to pre-process the data in Python. So first we need to resize the image, and then also convert the image colors. So resizing is important because the size of the image should be large enough that it should preserve all the details present in the image, and it should be also small enough to reduce the processing time and memory usage. So we need to make sure that the data have all the images have the same dimensions. So resizing is done basically to make all the images of the same size and reduce the uh, it also reduces the picture size and preserves the aspect ratio. So other is to convert the image into a standard color image, which is by using the RGB standard color space, because RGB standard color space is used by all the uh, and it is compatible with all the algorithms and libraries. So we have to make sure the color is in RGB so that it is displayed correctly in the monitor as well. So starting with the reading data, image data are my image data are stored in two different directories, cracked and uncracked. So I have used the function load and process image to load the image, and uh, CV2 image reader helps to read the loaded image. And for resizing I have used cv2.resize, and for changing the color I have used cv2.cvtcolor. So the output of this preprocessed data would be a numpy array which consists of a list of the images, For the normalization process, I have divided the image size by 225 so that the pixel values ranges from 0 to 1, 0 representing the non-cracked image, while 1 non-cracked pixel, 1 indicating the cracked one. So after the reading the dataset, we have to split the dataset into train test, and I have used the train test split function present in sklearn model selection. What it does, it stores the pre-processed image into a single array and stack it vertically, and y consists of the label of all this array. Here the values are 1 and 0 to 1. It's a binary classification problem, so 0 means uncracked and 1 means cracked image. So for the xy, these xy arrays are split into x train, x test, y train, and y test. I have used 50% data for the testing purpose, and the sampling should be done randomly, so I have used a random state of 1 2 3 4. So for talking about the model structure that I have used, my model uses the 4 convolutional layer with the 2 fully connected dense layers. So my first layer consists of the 16 filter with 3 class 3 kernel size. The activation function I have used is rectilinear linear function. In the first layer, I have used maximum pooling size of 2 cross 2. The input size of my image is 256 by 256, and from the pre-processing, I have also done the coloring to RGB, red, green, blue, which is a 3 color channel. So the second layer consists of the same 16 layers, 16 filters, 3 by 3 kernel size, activations of uh, rectified linear unit, and maximum pooling of 2 cross 2. The third and fourth layer consist of 32 layer filters though. And then I have a flattened layer to convert the output convolutional layer to single vectors, and I have used 2 dense layer, which is 2 fully connected layers. The first layer connects 32 neuron with using the rectilinear activation function, and the second layer use the sigmoidal activation function. So after the model is created, then the model is compiled. So for the compilation and training purpose, the optimizer I have been using in this model is Adams optimizer, because like its learning rate is high, and it test it during testing based on gradient of loss function, and the loss functions I will be using will be binary cross trophy, as it measures the difference between the predicted and actual probabilities. Metrics would be used for during model compilation to evaluate the performance of the model. It is used both during testing and training, and accuracy basically measures the proportion of correct classified image from the dataset. So after compiling the model is fit for the training dataset for 10 epoch, and in each batch size I have fed 16 images at a time. And after each batch, what it does is the model evaluates its own performance and updates its weights and biases, and then run the model for the second epoch. So what I'm looking for in each run is that in each epoch the loss function should be uh, decreased and the accuracy should be increased, and this was the output I got from running my model. So in the model evaluation, we can evaluate if the model is doing better or not by using the loss and accuracy function and also the ROC curve. I use the same developed model for the test dataset as well, and on the test dataset, my model showed the accuracy of 64% with the loss of 65%, and the model. And so the loss function basically shows how well model is learning the pattern, and CNN model is learning that is like it's learning 64%, and it generally uh, does the testing on the testing data set. Also, I have plotted the ROC curve. The area under the ROC curve I achieved was greater than 0.5, which shows that the model is better than a flip coin toss. So I use the same model to predict one image, uh, whether it's cracked or uncracked. I stored the image in different folder, and for the testing purpose I just use the same model. If it can predict this image perfectly or not, then the result obtained from running this code was the image is cracked, which is true for this condition. So the outcome from my CNN model was quite impressive for me. So thank you.